Hello champions! Welcome back to physics class. Today we are going to explore something very exciting, that is sound. Sound is all around us in nature, in music and even in our own voice. So let us try to understand its types and the characteristics that makes sound unique: pitch, loudness and quality. So are you ready? So let us begin. The characteristics of sound are simply types of sound. Generally in daily life we hear different types of sounds. Some sounds are very pleasant to hear, whereas some other sounds are not so pleasing enough. So based on this characteristic, sound is basically classified into two types. All the pleasant sounds come under musical sound, whereas those type of sound which are not so pleasing to hear are classified as noise. So here we go. Types of sound. Sound is basically classified into two types: musical sound and noise. Those type of sounds which are made by the regular vibrations or the periodic vibrations. The sound which is caused due to periodic or regular vibrations come under musical sound. Okay, so these musical sound have a definite frequency and a regular waveforms. Definite frequency and regular waveforms. So generally musical sound is produced by the instruments like sitar, guitar, violin, drum, even the waves, sea waves, chirping of birds. So these sounds are very pleasant to hear. So these are categorized as musical sounds. So these musical sounds can be reproduced because they have some definite pattern or definite waveform. Whereas noise are not having any definite pattern. So no definite waveform, no definite frequency. So these noise waves, whatever are there, so this is an irregular pattern. This is produced due to the irregular vibrations. Okay, so who produces noise generally? So noise is produced by the traffic sound. The traffic sound generally comes under noise. The horns by a buses, a truck, even the sound produced in a factory, all this are categorized as noise. Okay, children, let us try to understand the difference between the two, musical sound and noise, with the help of a graphical structure. Okay, so here we go. So children, these two wave patterns explain the difference between the musical sound and noise clear. If you observe the first figure, so the every wave format, either it is a crest or a trough, all are maintaining the same amplitude and have the repeated, these waves are repeated at regular intervals of time. That means they maintain the same frequency, same amplitude, same frequency. So like this. But if you observe the second figure, this is an example of noise. So one amplitude is different when compared to the other amplitude. Here less frequency and here more frequency. So they are maintaining different patterns. So the same noise cannot be repeated again and again. Whereas musical sound can be repeated again and again because it maintains the same pattern. Got it, children? So now let us move to the next topic, that is all about, that is characteristics of the musical sound. There are three characteristics of this musical sound. One is loudness or intensity. Second, pitch or shrillness. And the third, all about quality or timbre. So let us try to understand them one after the other. So first of all, what is loudness or intensity? So it is nothing but the property of sound which distinguishes the degree of sensation into our ear. I repeat, the degree of sensation into our ear is nothing but loudness. So how much we are able to hear that. So generally this loudness is a direct measure of intensity. So larger the intensity, we can simply say that more louder is the sound, and lesser the intensity, lesser is the sound. So like this we'll categorize. So how this loudness or intensity means, generally this intensity is nothing but, let me represent this intensity as I. Intensity generally defined as the energy produced per unit area per unit time. The energy produced per unit area per unit time is a direct measurement of intensity. Suppose if a body produces large amount of energy in a given surface area in a given interval of time, we say that it has more intensity. More intensity means the sound is louder. And if less energy is produced in a given unit area per unit time, then it has less intensity. So if the intensity is less, obviously the sound is also, that means there is no loudness. So you will be getting a faint sound. Louder sound and a faint sound makes a difference. Larger the intensity, louder sound. Lesser the intensity, faint sound. So let me give you an example for this. If you shout, then we are producing large amount of energy. Hence, large energy means large intensity of sound. Hence, louder. The voice will be louder when we shout. Similarly, when we whisper, we are producing less amount of energy. When less amount of energy is released, the intensity of sound will also be reduced, and hence we are getting a feeble or a faint sound. Okay, so this is how we categorize the characteristic of this loudness. So let us try to understand in detail regarding the factors that affecting loudness. Factors that affect loudness. Okay. The main factors that affect loudness are, first of all, amplitude of vibration. So loudness is a direct measure of the amplitude. If a body vibrates with large amplitude, it has louder sound is produced. If the same body vibrates with lesser amplitude, it produces less amount of sound. That means loudness is decreased. Faint sound is produced. Let me give you an example for this. Take a drum, beat it harder. When it beats harder, so the membrane of the drum vibrates with large amplitude. That means so loudness is increased. Similarly, if you beat the drum softly, then the membrane of the drum starts vibrating slowly with less amplitude of vibration. Hence, less amplitude of vibration means the loudness will be decreased. Okay, so the mathematical or the experimental relation between the amplitude and the loudness is given as loudness is proportional to the amplitude. And it was verified that the loudness is directly proportional to the square of the amplitude, and it was proved by mathematically applicable formula, and it was proved experimentally. So as amplitude increases, no doubt loudness increases, but in what form? So loudness always depends on the amplitude such that loudness is equals to square of the amplitude. Loudness is equals to square of the amplitude. And as we know that loudness is a direct measurement of intensity. Okay, larger the amplitude, intensity with the sound will be large. So even the intensity of the sound is loud, it produces large amount of sound. Okay, similarly, the second case, it also depends on the surface area of a vibrating body. Surface area of a vibrating body. How means loudness directly depends upon the surface area of a body. Let me give you an example for this. If you consider a large drum is beaten with some energy, then what happens? The membrane of the drum starts vibrating. So large surface area. Okay. So whenever the drum is beaten, whenever a drum having a large surface area is beaten, it produces large amount of sound. Similarly, if you take a small sized drum and you beat it, then because of the smaller area, it cannot produce large amount of sound as compared to the previous one. Okay, even though we are applying the same force on it. So what indicates means larger the surface area of the drum, it produces large amount of sound. So loudness is increased. Whereas smaller area of cross section of the drum, if you consider, the sound produced by it is decreased. That means loudness is decreased. Hence, loudness is a direct measurement of surface area. As surface area increases, loudness also increases accordingly. The next one is all about loudness depends upon the distance between the sound and the listener. Okay, so distance. Loudness also depends upon the distance between the sound and the listener. Suppose if the listener and the source of sound are very closer to each other, they can hear increased amount of sound. That means they hear it loudly. Whereas as the distance between the source of sound and the listener is increased. So as the distance increases, so the sound will be decreased. The loudness will be decreased. That means larger the distance between them, lesser sound. Lesser the distance between them, more sound is heard. That means loudness is inversely proportional to distance between the source of sound and the listener. So how are they proportional to each other means, so loudness inversely proportional to the square of the distance. This is the mathematical expression. So loudness is inversely proportional to the square of the distance between the listener and the source of sound. So next, the other factors on which this loudness depends on. Loudness also depends upon the density of substance. Loudness also depends on the density of the medium. Children, if you consider a dry air and a moist air. In dry air, most of which the dry air is occupied with oxygen as well as nitrogen. But whereas in moist air we have water vapor. So in water vapor means almost the molecules are filled with H2O. So we have, when compared to the nitrogen and oxygen and water molecules, so in which medium the loudness will be more means, the loudness will be more in the water vapor, that is moist air. So in dry air where it is occupied by the oxygen and nitrogen molecules, so we hear a feeble or less loudness is being heard. Okay children, so the loudness of a sound also depends upon the density of the medium. So more loudness, more sound or loudness, more loudness is observed in the case of moist air, whereas less loudness is observed in the case of dry air. Okay children, well, so next to that, presence of resonant bodies. Presence of resonant bodies. So already I explained you what is resonant bodies. Whenever the reflection of sound echoes and all, if you consider a big room, then whenever a sound is being produced, it is being reflected by the walls of the room, the floor, ceiling of the room as well as the floor of the room. So echoes are being produced due to the reflection of sound. Okay. So presence of the means the same noise or the same sound is being heard again and again. So this resonant bodies also affect the loudness of the sound. Okay children. So not only this children, this also depends upon the motion of the medium. How motion of the medium means, look at the wind. If the wind approaches us, the sound also travels along with the wind, and hence we can hear in a louder sound. Whenever the wind passes away from that, the direction of the wind is away from us, then we hear a less amount of sound or the loudness is decreased. So because of the motion of the wind also, the loudness of sound is been affected. So these are the factors on which loudness depends. I hope you understood children. So factors affecting the loudness. So amplitude of vibration, surface area of the vibrating body, distance between the source of sound and the listener, density of the medium, presence of the resonating bodies as well as the motion of the wind in and around us. Children, generally the loudness is measured in decibels. So measure of loudness. Loudness is measured, the unit of loudness is decibels, indicated with the letter dB. So let me explain in detail. Suppose if we are talking together in a low voice, we are able to listen to that sound, but in a low voice, if you talk together means, then that voice itself is considered or measured as 0 decibels. How many decibels children? 0. The low voice that can be heard by a human is generally 0 decibels. Suppose if we increase the loudness such that we talk with a louder voice. If you talk with a louder voice, then the loudness can be increased to up to 65 decibels. So dB, decibel indicated with the letter dB. If we talk generally or casually, it is measured in 65 decibels. Whereas if we whisper or talk very slowly, that is taken as your 0 decibels. Similarly, the noise produced in a factory is about 100 decibels. The noise produced in a factory is around 100 decibels. And if you observe a jet aircraft flying in the sky and produces some sound, and it produces a sound of loudness around 130 decibels. So based on that loudness that you hear in your daily life, you can categorize how much decibels the machine is or the object is producing. So next to that, let us try to understand, or let us move on to the next topic, the next characteristics of musical note, that is pitch or shrillness. Children, generally the high pitch sound itself is called as shrillness and the low pitch sound is called as a dullness. Okay, so how can you distinguish between two sound notes? High pitch sound or shrill sound or low pitch sound itself is called as a dull sound. Okay, so coming to the measurement of the pitch, this pitch is generally based on the frequency of the sound note. So pitch directly proportional to the frequency of sound note. But we know that the frequency of sound note is inversely proportional to the wavelength. Suppose if an instrument is having high frequency, then we can consider that its pitch is large. And the same instrument, if it is having less frequency, then we term it as a dull sound. Okay, the instrument, if you are given to, many instruments are given to you, producing different sounds and all, and we are playing the instrument in different frets and notes. Any instrument played in the same frets or same note having the same pitch. Okay, so number of frequencies, when number of vibrations in a given time itself is called as a frequency. So pitch is a direct measure of the frequency. So more number of vibrations per minute means more pitch is being produced. Less number of vibrations per second is produced means the pitch is low. Okay, that means a dull sound is being produced. Wavelength. As we know that frequency is inversely proportional to wavelength. Wavelength means the distance between any two crests or any two troughs is generally taken as your wavelength. So something like this. So if the wavelength is large, you have less frequency. The same case, if the wavelength is less, you have large amount of frequency. So larger the wavelength, lesser will be frequency and vice versa. Okay, let me explain this with a proper example. Let us compare the voice of a female voice and children voice when compared to the male voice. We observe that the pitch of the female voice or children is comparatively high when compared to the pitch of the male voice. So the male voice is generally termed as a low pitch sound. That means the male voice produces a grave or flat sound, whereas the chirping of the birds, children or female they produce large amount of sound. Pitch, their shrillness or the pitch will be large when compared to the shrillness of the male voice. This is how we compare the pitch of any sound producing objects. Okay, children. So this is all about your pitch. Not only this, children, if you observe the flattering of the mosquito wings or the bees, so they produce large frequency. They flatter their wings with a large frequency. The reason why the pitch will be more whenever a mosquito or a bee passes by. Even in the Indian music, you observe the notes like sa, re, ga, ma, pa, da, ni. So among all these, ni will be having the higher pitch. This is all about pitch, my children. So now let us try to understand the next characteristic of this musical note is nothing but quality or timbre. So how quality or timbre makes difference between the above two characteristics, that is loudness and pitch. Suppose if an instrument produces same note having the same loudness and same pitch, but still the voice can be identified because the quality or timbre will be different in both the cases. Let me explain in detail. If you observe sitar and a guitar or a flute, if the three instruments are played in the same note having the same frequency and in the same loudness is given, but still we can identify from which instrument the sound is being coming, whether it is the sound is coming from a flute or a guitar or a tabla, whatever it is, we can able to identify. The reason behind it is the timbre, the material itself is varied. Not only this, children, suppose if two persons are singing or two persons are talking, even on a phone, we can identify the voice of the other person based on the quality or the timbre of the given person. So I hope you understood what is quality or timbre. So each and every vocal cord, it might be Lata Mangeshkar, SP Balasubramaniam, Asha Bhosale, or whoever it is, every individual are maintaining their own timbre or quality. So based on that quality, we can identify the voice or the instrument by which the voice is being the sound is being coming. So this gives the actual measure of the timbre or quality. So let me explain the same with the help of a graph. Let us suppose that three different instruments maintaining the same amplitude. Same amplitude means same loudness. And they maintain the same frequency. Same frequency means same having the same pitch. But the quality or timbre itself makes a difference. Let us see how it looks like. Observe the three waveforms, children. These three waveforms have the same amplitude. They maintain the same frequency, but what makes the difference means the material itself makes the difference, because the vibrations in this is comparatively different. Here it is different and here is totally different. So based on the timbre or the material used or the vocal cords or whatever it is, so based on that again sound is categorized into other case, that is quality or timbre. So with this, let us conclude this concept.